It seems to have slowed down. I guess so there's one more person coming on. Well, I'll begin an introduction then, and we can get started. Welcome to sort of a special Cyberseminar series from Quasi on the new HydroShare program. This is Rick Hooper. I'm the president of Quasi, and I'm very pleased today to be able to introduce Dave Tarboton from Utah State University, who has been working on this project now for, let's see, about 4 years now, right, Dave? And it's reaching a point where it's usable, and we're encouraging people to try this out. From my point of view, this is going to be a very important aspect of meeting your data management plan. I see Wendy Graham is on the line, and so this is an important thing where at Quasi we want to be able to say that when you're done with your NSF project and need to publish your data, we want to have a simple answer is yes, we can publish your data, and HydroShare is going to be an important way to get us there. So with that, I will just turn it over to Dave to let him begin to describe this new project.
Well, thanks, Rick. Super to be speaking to you this afternoon. So this is the first of a set of webinars to present HydroShare to the Quasi community. This webinar is going to focus on what HydroShare is and how to use it to share and publish your data and models. And I really appreciate the opportunity Quasi's given to present this work. HydroShare is cyber infrastructure developed with NSF support and in collaboration with Quasi. It's a 4-year project, so it's got one more year to go, and then we'll have to figure out what proposal to write next and how to sustain it. And we've got discussions with Quasi going on in the Water Data Center for that already. But it's designed to support collaboration, data sharing, data publication, and data management needs of the broad Quasi hydrology community. Let me switch into the slides I've got. What you've been looking at here is the landing page for the website. So HydroShare is a system that you can use in your research to make results publicly available, initially to your co-workers, students and colleagues, and eventually to the public. You can formally publish data. You can get a citable digital object identifier to allow you to get credit for the data and model products you generate, and by doing that make work more transparent and reproducible, which then enhances the credibility of your research results. I'll be demonstrating some of its use, and we hope that it's easy to use and that it provides additional metadata that makes it more effective than perhaps general purpose file sharing systems such as Google Drive or Dropbox, because you get the complete metadata and hydrology specific metadata that goes along with it. We've chosen to keep content in HydroShare using what we refer to as resources that are structured specifically for hydrologic purposes that can support visualization, analysis, and modeling. So there's the title of the seminar, Share and Publish Your Data and Models with HydroShare. I should really acknowledge the team that's behind this, built this great system, and it's been great to coordinate this effort. So the outline of what I'd like to cover is a bit of motivation for working with HydroShare, then give detail on what HydroShare actually is, why you should use HydroShare, what's in it for you. Then I'll leave the slides and show actual use of HydroShare, demoing the creation of resources, the discovery of existing resources. Then I'll switch back to the slides and show how HydroShare works and some of the new functionality under development, and I'll end up talking about where you can learn more. This is the first of a series of seminars, so I'll give a slide that gives the other seminars coming up. They're also listed on the website that you've got to come to this seminar. So the motivation really started from the premise that hydrology is a team sport. Advancing hydrologic understanding requires integration of information from multiple sources. Oftentimes, the data integration analysis we need to do is computationally intensive, and it requires collaboration. I think that the days of a single investigator making a single set of measurements in the field and discovering something new just from those measurements are probably over. But if you make a set of measurements, then combine them with the measurements of other investigators to gain a fuller picture and deeper understanding, that's how we're going to get advances. So we're really looking at, if you think of in terms of National Academy or National Research Council grand challenges, ways to produce better hydrologic forecasts, for example, to quantify the effects of land surface change and hopefully protect against floods and provide water resources through droughts. And we're going to be doing this through collaboration and teamwork with data, analysis, and models. Collectively, we think of data and models in HydroShare as resources. And this little picture here is depicting that there's people working together and using resources in the computational cloud. So we're trying to think of work in cyber infrastructure where it doesn't necessarily matter where the server is that you're working with. The size of data that we work with as hydrologists has increased over the years. And this relates to some of my specific work with digital elevation models. When I started working on this in the 1980s, you could characterize a 50,000 square kilometer watershed with 27 megabytes of data. Today, when you've got LiDAR, perhaps at a 1 meter cell size, you've got 200 gigabytes of data, a factor of 10,000 increase in 30 years. So now I know computers have increased incredibly in terms of speed and storage during that time, but we still need to work on the algorithms and models to take advantage of this data deluge, really. There's also a challenge of heterogeneity of data. Often in a hydrologic study, you'll be integrating information from dispersed federal agencies that's been collected for different purposes. You get data in different formats: points, lines, polygons, spatial fields, time series. And when I started working with the quasi-hydrologic information system, that was effectively the starting point of my work in hydrologic information systems that has culminated in development of HydroShare. One of the things I learned was that the way data is stored can enhance or inhibit the analysis that can be done. We need to work on ways to organize the data we work with, and it got us to thinking about data models, and some of that has persisted into HydroShare. So now, I guess we're not the only people who've noticed that the internet came along and that people are interacting closely on the internet. And in fact, as hydrologists, we are fairly small players in the area of big data. And I just want to reflect briefly on how people have learned to share content now on the internet and what message that has for us. So I've got a presentation or an image from YouTube where I was actually talking about HydroShare. I've got Quasi's Facebook page. YouTube has really revolutionized the way we share video. Before YouTube, if I wanted to send a video of my children to my parents in South Africa, it was hard, if not impossible. We were dealing with low bandwidth, incompatible formats, and limited expertise, and those three basically made it not happen. Now with YouTube, I can simply upload a video in whatever format it comes off, whatever camera I'm using, and it just works. Similarly, Facebook and Instagram have made it easy to share photos. Dropbox and Google Drive have made it really easy to share files. We also learn from YouTube and Facebook that people are starting to treat their content as social objects around which they interact. And what we're trying to do with HydroShare is provide a place for people to share hydrologic data easily, perhaps as easy as it is to post videos on YouTube. I would submit that right now, if you are sending somebody hydrologic data, you can get them the files as perhaps quite quickly using Google Drive or Dropbox, but explaining what the content is often a painful barrier, and we want to help ease that through having metadata somewhat naturally captured, and also letting the hydrologic resources become objects for collaboration, thinking of them the same way that Facebook thinks of photos and YouTube thinks of videos. You might ask, why not just use Dropbox or Google Drive? Both are inexpensive, free for their sort of starter quotas, and the reason really comes down to this one of metadata and the time it takes to explain what the content is. So HydroShare is a system for sharing hydrologic resources and collaborating. When we talk about resources, we're talking about files and sets of files structured to represent a hydrologic process, model, or elements in the hydrologic environment. We've focused on standard data models to enhance interoperability and support functionality that can act on the files. We've provided a way for people to develop tools or web apps that can act on resources that would hopefully encode good or standard best practices. And we've carefully thought about the access control and sharing model to make it easy for people to know who can see their files, so that the right time to make it public, they can make it public easily. This diagram at the right sort of shows the way we organize thinking about it. The system has to support storage of the resources, and we are using IRODs for that. It has to support discovery and management of the resources that are there, and there's a Django website for that. And it has to support actions on the resources through apps. So when we think of the data involved, this is from a federal government circular that notes that research data is recorded factual material commonly accepted as necessary to validate research findings. Not limited just to the raw data, but also including models, code, scripts, simulation results. So HydroShare needs to accommodate all of those types of data. So one of the points that takes HydroShare beyond what the quasi-HIS currently can do is that we've got many other data types than effectively point observation time series. That was the focus of HIS. We've added geographic rasters, features, multidimensional space-time data, and so on. So this is some of the data and models used that need to be included. Time series, obviously, geographic rasters, geographic features. So rasters where the information is represented in a grid, and that's the natural way of representing a spatial field. Geographic feature is where the object is represented perhaps with points, lines, or polygons, and that's the natural way to represent discrete objects in a landscape. Then oftentimes we have multi-dimensional data. So you might have a field of information in X and Y at different snapshots in time, or continuously in time that's discretized in terms of snapshots. Then you also might want to have the complete code, and maybe even the executable for a hydrologic model, and what we refer to as a model instance, which is the model program plus the input files and the output files for its application at a particular site. So in HydroShare, you can right now go and share your data and models with colleagues. You can manage who has access to the content that you share. You can visualize and manipulate what I was calling a broad set of hydrologic data types and models. Certainly it's not all types and models, but I think it's enough to give a fairly comprehensive description of any set of model inputs or any environment. You can use the web service application programmer's interface to automate work with HydroShare and have other clients work with it. You can publish data and models to meet the requirements of a data management plan, receive a citable digital object identifier, so the data then becomes locked down, unchangeable, and will get persisted. You can access data provided by others and use web apps to visualize, analyze, and eventually run models. Some of the later seminars we'll be talking about how to actually do that. So this is where I didn't want to go there, but I want to actually switch into the website. So this is the landing page. If you haven't been here before, the first thing you might want to do is sign up and get an account, and anybody can get an account quite quickly by just entering your name, institution, and email address, and then there'll be an email sent that you can click on to validate that that is a valid email address, and you'll have an account. You can also discover public resources without having an account, and I'll do that right now. So I'll click on the Discover tab, and you start seeing a listing of the content that we have. So John Sharkey has a number of first authored resources, and those I believe are the MOPEX data that Quasi has actually been working to load just recently. Let me do a search on Logan to find the resources that I wanted to show you to sort of demonstrate. So now I find the resources in the Logan area, Utah State University's in Logan, Utah, and here are a couple of resources that I've prepared. The first one is a collection that I called Logan River Geography, and then there's a couple of things, the digital elevation model, a stream network, and the contributing area. If I click on the link that's on the title of the collection resource, you'll see this is what we refer to as a resource landing page, and there's a number of things that I want to point out. Each resource has a title. It's an important part for identifying it. It has a separate list of authors and owners. The authors are the people who've been responsible for intellectually creating or developing the content, and they do not necessarily have to be HydroShare users. The owners are the people who are users in HydroShare who basically have loaded the file and manage the access control and rights over it. In the case of this collection, I made it, so I'm the author as well as the owner. There's a place where one can write an abstract, and maybe I should have written a more extensive abstract. Each resource has a unique identifier, this GUID or globally unique identifier that starts 2ADEE16 and so on. And then when that is put at the end of the HydroShare URL/resource, that becomes a unique URL for this resource, and there's information on how to cite it. Each resource has a license. So when you are creating a resource, you get to choose whether you're publishing it, say, under the Creative Commons license or some other license. There's subject keywords. Because this is a collection, you'll see it's actually comprised of 3 other resources: the Logan River Stream Network, the Logan Specific Catchment Area, which is one of the digital elevation model derived fields that goes into wetness index, and then the actual digital elevation model. those two are raster resources, and the stream network is a geographic feature. Scrolling on down, you can see that there is other metadata involved. Here's where the authors are, more detail about the authors. So I've got my institution and phone number in there. I've filled out credit information. So I've said that this resource was created with support from the National Science Foundation under this project. This is actually the title of the HydroShare award, and that's because I created this resource for sort of demonstrating the capability, and there's the award number. So agencies are getting credits, and then we also have places where people can write comments on resources, can plus one it in the sort of social context to add value. I can click on coverage, and you'll see where it is in a map. And I also filled out the place area name, saying this is in the Bear River Range east of Logan, and it gives the coordinate system. So for those of you who are sort of picky about geographic details, you know what that coverage precisely means in a geographic information sense. So let me go to the stream network resource. This has much of the similar information, but now it's just indicating that the type is a geographic feature. We are choosing to use Esri shapefiles as the format that we store geographic features in, because that's a fairly well understood open format. Those of you who are familiar with shapefiles will know that they are comprised of multiple physical files, and there are the 5 files that make up this resource. I can do something like download the entire content as a zipped Bagot archive. You might ask yourself, what on earth is that? That's a format developed from the Library of Congress for effectively storing data and metadata in a sort of reproducible and standard way. So I downloaded that zip file. You might have seen it got saved there, and so there's a folder that has the GUID name in it. Inside it, there's a couple of the files that represent the metadata associated with it. If I look inside, there's additional resource level metadata, and I can go into the contents and see the original shapefiles. If I wanted to look at one of the metadata files, I can open them, and this will actually open in my system on Dreamweaver, because I've got Dreamweaver as my system for viewing metadata. And there you can see it's got things like the title, the abstract. It's got a lot of XML information that represents that metadata. So when you download the complete resource information, you get all of that along with the data. And one of the papers that I have a reference to that at the end is written by Jeff Horsburgh on our resource data model, describes that in a fair bit of detail. I can also see where that watershed is, and I can look at the specific information associated with the shapefile, and here you'll see that the actual data for the shapefile is in a different geographic coordinate system. So one of the things that HydroShare takes care of is that when you load information that metadata is about geographic coordinates is already known, it'll convert it to the standard that we're using for representing coverage, so helping you with keeping track of metadata without you having to do too much about it. I showed in the little diagram we had of how HydroShare was structured that there's the concept that we can have apps to look at resources. So I'm going to open this with the HydroShare GIS app. This is actually going to launch, if you look at the bottom left, you're seeing it's launching apps.hydroshare.org, which is now a separate web server within the sort of HydroShare system that's going to launch. When we open apps for working on this particular app, you need to be signed in. So I'm signing into to the account that I'm using for demo purposes into that the server. It's also asking me to authorize, and you can think of this as similar to the authorization you would give when you try to run a new app that you've just downloaded on a smartphone. In this case, I'm authorizing that app that I connected to be able to read and write into my HydroShare files, because it really is a different computer, and one of the extensible models of HydroShare is that anybody can actually set up an app server. So there's this need for trusting the server that you're using. So here I go ahead and authorize, and now it says that it's opened this GIS app, and I can I guess one may say that these pop-up boxes initially may well, when you use it a lot, they sort of annoying. You just want to close it, but we've tried to include quite a lot of pop-ups that say what this app does. So you can add a base map, you can add a layer to the view. In this case, it's developed by the BYU group that's part of the HydroShare team, and they provide help information for how to use that. And then we see now we've got the shapefile displayed just on a blank screen, but if I want to put the sort of base map for roads behind it, I can do that. I don't have to have only one layer on the server. I can then also have other things. So I think I showed you in the collection, in addition to the stream network, we also had the digital elevation model. So I'm going to add a HydroShare resource. I'm going to do a search on Logan. I'm going to pick the digital elevation model resource and say I want to add that. So it takes a little while to load it. Now that we've got a bit of an issue with the color schemes that we're going to be working on, it doesn't right now recognize the range of the data. So I'm going to have to, I know for this data that 1500 is a minimum bound, 3000 is an upper bound, and I can set the colors associated with each of those. I can also grab the stream network and put it above. So now I'm starting to build up a bit of a map that shows the elevations and the stream network, so helping me visualize the resources. And let me, I'm also able to save it, so I can save this, and it'll now ask me the name of the resource I want to share it to, or save it as. So I'm going to call it the Logan map, and it's filled out an abstract and some keywords, and maybe I also want to add the keyword Logan there. This resource will then now be saved. So let me close that. So let me switch back to where I was in HydroShare in the main website, and click on My Resources. And now you can see that I've got this Logan map resource that was just created. So I'm actually using a demo account that previously didn't have any resources in it. So this is a way that you can actually start to visualize and work with data that's already in the system. What I want to show next is how you might actually publish and share some of your own data. So I'm going to go to create a new resource, and I'm going to illustrate the case of loading a digital elevation model. So I'm going to switch to, so now there you are seeing the different types of resources that we can have in HydroShare. You can have multidimensional in NetCDF format. You can have a web app, which is effectively the tool that something like HydroShare GIS for visualizing geographic data. You can have a collection. You can have geographic rasters and features. You can have time series and reference time series. So the distinction between those are that a time series is you've got the actual data that's stored in HydroShare. HIS reference time series is we've decided that the quasi-HIS system that has a time series in it is perfectly fine, and we're just going to provide a link to that because there's no need to replicate the data. You can also see in terms of modeling, we've got a model program, a model instance, a SWOT model instance. We're Venkatesh Marwadi is on our team, and he's got the system called SWOTshare that interacts with SWOT models. That's the soil water assessment tool model that's quite widely used. And then you can also have scripts like an R script or a Python script. In this case, I'm going to go to geographic raster. I'm going to browse to select a file. I'm going to navigate to where I have my folder full of files for demoing, and I'm going to go to where there's a DEM, and I'm going to go to the Cub River, and I'm just going to pick a GeoTIFF file here, and I'm going to say open that, and let me fill in the title, Cub River. You can see that I've done this before because the autocomplete on my browser is helping me out. So let me then do create. So now what is happening is the system is importing this digital elevation model and making it into a geographic resource in HydroShare. Now it's finished, so it's automatically populated things like the author, the owners. You'll notice that in addition to the TIFF file that was loaded, there's also a VRT file, and that's because of the specific format we're using allows a geographic raster resource to be built out of many files, and this is a file that sort of points to the many files that belong to that. I could do the bit about downloading the bag that I showed earlier, and I can see that the authors listed as me with the organization of Utah State University. And if I go into coverage, I'll see that this information is actually known, and that's because the resource came from a GeoTIFF file that has location information as part of it. So this is metadata that a user did not need to write. If I go to resource-specific information, I can see information about the rows and columns, the cell size, the geographic coordinate system, but I see that the system doesn't know what this really is. It just says it's got one band in it, and the variable name and the variable units are unknown. So if I want to share this with somebody, I actually want the system to keep track of what it is. So I'm going to actually go and edit this file, and I'm going to go down here, and where there is resource-specific information, I'm going to then say that this variable is actually elevation. The units are meters, and the method, this is extracted from national elevation data sets from the USGS, and maybe I want to put comments. This covers the Cub River Basin. So you can fill in metadata associated with each layer as needed. Save the changes, And now that becomes part of the resource. When you download the bag, you'll get that as that'll be held in the metadata file. I could add the funding agency if I wanted to report the grant that had supported me doing that work. So you'll notice if I try and click on public or discoverable, that's not those are not activated. I need to actually add additional metadata before I'm allowed to make something public. Let me add a keyword, elevation, and I'll add that. And I might also add in the abstract, so say this is Cub River DEM. I should probably write a bit more. And now you'll say metadata is sufficient to publish, make public. So the system actually keeps track of, it requires every resource that you want to make public have an abstract, have subject keywords, and have certain metadata available. So maybe I'm not ready to make this public yet, though. I'm possibly this is sort of work in progress, but I want to share it with my collaborators to give them access to it, or maybe I actually wanted them to add the metadata because I might not have known it, or I might be collaborating with my students. So I can click on the Manage Access button. So you'll see here, if you hover over it, it sort of explains what that button is. And then it says, right now, the only person who has access to this resource is me as the owner, but maybe I want to, notice I can add users and or groups. So I'm going to say, put Rick Hooper in here. So if I just start typing his name, I can get him there, and maybe I'll make it so that he could actually edit this resource. So if you allowing somebody to edit this resource, they're actually you're effectively trusting them to be able to change it. Maybe there's somebody else. I'll find one of my colleagues here at Utah State, and I'll say that they can just view the resource. So you can manage whether people have permission to edit on the content, or whether they have an ability just to view the content. So and then I'll close. So now that this resource is accessible to them, and it's effectively shared, but it's not yet public. And the idea is that you could work collaboratively and dynamically just among your team, and then as soon as you're ready to make the data public, you would make it public. Let me show you one more thing. So let me go into my resources and show the creation of a multidimensional resource. So I'm going to click on create a new resource, multidimensional netcdf. I'm going to browse, and I'm going to select this file named SWE. That actually stands for Snow Water Equivalent. Notice I'm not going to fill in the title. And that's because with netcdf files are actually very, very rich in the metadata that they can hold themselves. And we're using the CF conventions, or the climate forecast conventions. And if a netcdf file has metadata according to those conventions, HydroShare will automatically read it. So it's now created this HydroShare resource that has a title that it received from the netcdf file. It also got subject keywords from the netcdf file and an abstract from the netcdf file. So it's got a lot of the sort of things that you want. So the whole idea is that passing around files with rich metadata becomes quite natural in HydroShare. I can go and click on where the spatial coverage of that is. I can click on the resource-specific metadata information, and I can see some information about this particular netcdf file. It has 5 variables. 2 of them are dimensions, or actually 3 of them are the dimensions, the x and the y and the time. And then the snow water equivalent is a 3-dimensional array that gives snow water equivalent of time, x and y, in a grid over a watershed. And then the transverse Mercator just shows the coordinate system. For those of you who are familiar with netcdf files, you'll know that you can run the program ncdump to effectively extract the header metadata information, or ncdump with the -h flag. We've chosen to show that information as part of the HydroShare metadata. So here, this is the result from the ncdump on that file, and you can sort of read all the gory details for those of you who are familiar with netcdf. With relying on netcdf files for the multidimensional space-time data, we are able to leverage a lot of the functionality that's already come out of the atmospheric science community with NCAR and Unidata developing and supporting the netcdf format. Let me go into edit this resource, and because I've got a complete set of metadata on it, I can actually make it public. And when I do that, this is going to just take a few seconds to run, because if this little note here says, note that making this resource public may take extra time to update the HIRAX server in order to provide OpenDAP service for this resource. So OpenDAP is an Open Data Access Protocol web service that comes out of the climate community for effectively publishing data from netcdf files. And we've got HydroShare set up so that any netcdf files that are public can be accessible through this service, and therefore can take advantage of all of the software that's available for dealing with data in OpenDAP. So now that that is finished, so this resource is actually now public, and if I go down to the resource specific tab, you'll see that there's a new entry that says, here's the threads data service, and I can click on OpenDAP, and now I'll get a link that's, now we've moved away from HydroShare again onto this HIRAX server. Well, still on the HydroShare domain, and they're all effectively operated at RENC, which is the computing center that's supporting this. But here you can see the URL for the data, the global attributes, and this is your standard OpenDAP server data access form. So you can do things like select on the variables that you want to subset on, and connect things like the integrated data viewer from Unidata or other visualizing systems to access this data, and subset this data if it happens to be large. So let me go back. One more thing that I wanted to note is that I could click on one of these buttons. I could click on this button to publish the resource. So if I do that, that would give me a citable digital object identifier. So it says, upon submitting this resource for publication, it will be permanently published, assigned a DOI. This is final, and you have to agree to the HydroShare publication agreement, accept all the changes, and then publish. Now, I'm not going to do that because I don't actually want to persist this resource forever. But if you need to get a citable digital object identifier for your resource, you can do that. So I think that's covered all of the things that I wanted to actually show you how to work with in HydroShare. There were several, well, I guess there were several other kinds of apps, and if I just click on that, you'll see them. And many of in some of the follow-up webinars, we'll be talking about how to use each of those. But let me just switch back into the PowerPoint slides and talk to you a bit about how it works. So I showed earlier the slide of the sort of organizing paradigm where we have iRods as supporting our distributed file storage, the Django website for resource exploration, which is where you can organize and annotate your content, manage access, the development of apps that perform actions on resources, that's web software to operate on the content you have. And we've carefully architected this so that anyone can set up a server or app platform, which is really a software service, to operate on HydroShare resources through iRods and through the API. And we've got a couple of examples of that. So later on, there'll be a seminar about SWOT Share that allows you to effectively access SWOT models in HydroShare and run them on the Purdue SWOT Share system, which is based on Hub Zero. You can actually connect to CyberGIS. We saw the connections to Unidata for threads and hierarchs, and there's Land Lab working with Christina Mandaragota and Erkan Buloglu and University of Washington on that. And iRods allows data to be shared across multiple systems. So it does parallel a little bit how PCs are used. You can think of this as your hard disk or your set of hard disks. This is your file explorer, and these are all the programs or apps that you have on a PC. So in terms of the functionality, there's sharing and publication of data with DOIs. There's social discovery and added value. So that's through the comments and ratings and also the formation of groups. In the next seminar will be by Jeff Horsburgh talking about that. You can also build up model input data and share that so that you've got effectively completely reproducible science to support transparency and get credit for the data you produce. Then I think there's this idea of clearing your desk, doing things in a server or cloud computation environment that's platform independent. You'll notice that the work that I did here, I didn't have to have any GIS on my system, yet I was visualizing GIS data. I can actually work with quite large data without having the bandwidth on my computer. So there's a reduced need for installing software, and it's more reproducible in terms of other people being able to understand what's been done. So you would have seen a bit about the access control model, but these are the key elements, and there's a lot of words here, but I'll just leave it for you to sort of read it. Owners can perform all operations on a resource. Editors can edit resource content, and viewers can just view content and perhaps download files. Then we have resource access settings that may be either public or discoverable only if you want the metadata to be visible, but you want the data protected. Published when you have a immutable, citable DOI. Private when you're just working with your team members and members of groups that you've specifically enabled access to. And then shareable when you want other people who you've given access over the resource to actually be able to extend that permission to others. So there's a set of fairly simple concepts that hope make it transparent in terms of who's got access to the data. The automatic completion of metadata, where it comes from information that's part of the files that you get, and taking advantage of things like the CF conventions for multi-dimensional data. So this is an example of the sort of visualization, if I decided to do the demo showing Panoply, we could have developed graphs like this from the NetCDF resource that I showed, and also time series like that, just by effectively subsetting the data across a different dimension. This is all moving towards the idea of effectively cloud or network computing, and asking, can we deliver hydrologic research and analysis functionality as a service over the web, thinking of all of the servers involved, software as a service, and the users can collaborate with the system wherever they are. So apps are part of that. And this is showing one of the apps is actually doing hydrologic terrain analysis, taking advantage of high-performance computing at the Cyberseminar Center at the University of Illinois. We've got further functionality under development to effectively extend some of the programming and model input data preparation capability, develop additional apps, develop additional loading and visualization functionality. So where the system is right now, it's a new web-based system for advancing model and data sharing. You can access multiple types of hydrologic data, so getting beyond time series into geographic features, geographic rasters, multi-dimensional, using standards to effectively allow people to build apps against it and also be interoperable with other systems. There's a flexible discovery functionality. I didn't dwell much on that, but you can search on keywords, you can filter on a map. You can share models and execute some of them. And by executing models on high-performance computers, you'll be able to sort of ease access to high-performance computing. There's collaboration functionality, links to other modeling systems that ultimately we hope can enable more rapid advances in understanding through the collaboration involved. So these are the upcoming webinars. In 2 weeks' time, Jeff Horsburgh will talk about collaboration with HydroShare. Then Dan Ames will talk about apps for web-based hydrologic analysis. Then Venkatesh Mawade and Jeff Sadler will talk about sharing and publishing models with SWOT-Share. And then we've got a workshop at the Quasi Biennial coming up in July. This slide gives some of the papers if you want to go and read more about any of the details. And those give the wonderful people that have helped build the system. And I'll be happy to answer questions.
It looks like there's a question in the chat box.
So I guess I have to find the chat box.
So David Goodrich says, besides the automatic checks you have built into HydroShare for creating a DOI, is there any additional review or vetting process analogous to the peer review process?
And the answer to that is no. And maybe there could be some discussion about whether perhaps there should be additional review. But there's two issues with, we did discuss this quite a lot in the team. There's two issues with doing that. First, you have to have an organization, set up an organization to do the review, to do all the vetting. And then at some level, we're still fairly early in the process and we want to attract users to the system. And right now, I can actually go and get a DOI without any review from a system like Figshare. So we don't want the fact that, oh, I could get a DOI from Figshare, but I'd have to go through this whole review with HydroShare to sort of be an entry barrier. But I mean, but the point is important that there is a concern over quality. Anybody could publish information and maybe it's poor quality, and now they've got a citable DOI for it. We're hoping that we can crowdsource some of the quality control through things like, well, the plus-oneing and the commenting on resources.
All right.
So there's a question from Temple University.
Mm-hmm.
Can the metadata files be edited both before and after they're public? Editing the metadata file is needed to add sensors to a site. So the answer is, well, maybe we have to be careful about the semantics. Yes, once the files have been added, you can edit the metadata up until and the data, you can make the data public, but we are using the word published in a special way. Once you publish the data and you assign it a digital object identifier, then it becomes immutable, and you cannot edit it. So this is similar to a journal article. You might have a journal article as a preprint on your website, and it's under review. You make changes, but once it finally goes into press, that's it. So David Genero asked, how do you explain the similarities and differences between HydroShare and the water data center? So that's a good question. So the water data center is a facility that Kwazi is operating to enhance access to water data for the hydrology community. HydroShare is a system being developed by the team of people that you can see on the screen in a project funded by the National Science Foundation. So at some level of it, it's a project that comes to an end in a year's time. We would like, and Kwazi would like, for HydroShare to be supported at the Water Data Center in perpetuity, or at least the parts of it that work. I mean, we're thinking this is a development project, which is always an experiment. We try some things, many of them work. Some things we try don't work. And just as with the Kwazi HIS, there was a development project, then it was made operational at the Water Data Center. There's plans and discussions to make HydroShare operational at the Water Data Center. So Trent Biggs asked, for documenting the code used to generate data, example, the rating curve used to generate a discharge, is the best option to include a URL to a Jupyter workbook in the metadata or link to a GitHub repository? So I think that either could be good. I think what we want to do in HydroShare is not do what other systems do well. So GitHub is a very good website and system for managing code, for keeping track of versions of code. So if you've got a model in GitHub, in HydroShare, we should actually just be pointing to GitHub. And Brian Miles, who actually developed a lot of the model thinking, is one of the people in the picture here, in the glasses in the back row, actually has set up Rhesus, has set up the model instance in HydroShare so that it can point to a specific commit in GitHub rather than maintain the code. And he wants to have it so that when you run a model, you'll pull the commit from GitHub, you'll compile it, and you'll run it. Sometimes you'll have, sometimes Git may be overkill if it's a fairly simple R script, and I don't know how complicated you want the program to generate discharge from a rating curve, because that's often just a polynomial function. You may want to just express in metadata what the polynomial function is, or include an R script or a Python script for doing that in HydroShare as part of the resource. So it could be done either way. I think that one thing related to that question is we don't actually always know what the best practices are, And I think many of them are discovered through actual use. So the idea is for the system to be fairly flexible, and then we'll learn from the use patterns. So Laurelyn asked, what sort of data models should not be uploaded to HydroShare? For instance, synthetic data to illustrate algorithms, raw data process. I think that anything that's used for hydrologic science should be fair game to upload to HydroShare. It's not only a system for publishing field observations, it's a system for effectively documenting and making your research transparent. Let's go back to this, to where was this slide that I had about the sort of definition of data. So whatever it is that you need to support your results should be able to go into HydroShare. So any other questions? I see Laurelyn is typing. Just thanks. Anybody want to blurt something out? I guess you're all on mute.
Dave, this is Rick. I just wanted to kind of add while people are typing that you know, we at the data center are trying to gather use cases for using HydroShare, and Liza Brazil at the water data center is our user support person. So it's not that Liza is an expert, but she's very happy to work with you if you explain what you're trying to do, and if you're running into troubles, that we can work on this with the development team to see how to solve it. We've had some examples of like uploading multiple years of GIFs to be able to look at the High Plains Aquifer, you know, and looking at different solutions to that problem. So just want to put that out there, that we're really, Quasi's actively supporting the use of HydroShare during this last year of the project.
And Liza has my phone number and much of the development team's email. So.
Yes, exactly.
So if she doesn't know, she can try and get the answers.
So I don't see any other questions coming in. And we are at the top of the hour.
So maybe we should just remind folks the next seminar, 2 weeks' time, Jeff Horsburgh, collaboration with HydroShare. Jeff is on the line, so if he got unmuted, he could give us a quick...
Yeah, star 6, Jeff.
He may not be ready for
I want the suspense to continue.
Okay, anything else then, or?
So let me just say thanks everybody for listening, and try and use, if you go and use HydroShare, and if something doesn't work, recognize that it's a system that's under fairly rapid development, and we would certainly welcome your feedback, even if it's pointing out a problem that something doesn't work, because we'll do our best to try and fix it.
Okay, should we wrap it up then, Dave? Or?
I think we should wrap it up.
Very good. Well, thank everybody for coming. Appreciate it. It was a good turnout today. And just as Dave said, 2 weeks' time, there'll be another webinar, and then that's leading up to the biennial at the end of July. See everybody then. Thanks.